CE327L, Sieve Analysis and Overview. The purpose of sieve analysis is to determine the grain size distribution of your soil for the purpose of soil classification. The result of this test is a grain size distribution curve. This curve is a plot of soil diameter versus the percentage of the dry sample by weight that is smaller than that diameter. Most natural soils contain a variety of particle sizes mixed together. There are three general classifications of soil by size: fines, sands, and gravels. Fines are any soil passing the number 200 sieve and consist of clays and silts. Gravels are any soil retained by the number 4 sieve, and sands fall in the area in between. The particle diameters that correspond to certain percent passing values for a given soil are known as D sizes. For example, D10 is the grain size that corresponds to 10% passing. Two additional parameters, the coefficient of uniformity C sub U and the coefficient of curvature C sub C, are based on D sizes. According to ASTM standard D422, the test consists of preparing a soil sample with a known weight of solids, W sub S, and passing it through the sieves. It's very important to select a representative sample of your soil. Depending on your largest particle diameter, your soil sample can be as small as 500 grams or as large as 4,000 grams. Follow the table shown in the lab manual to determine your representative sample size. The sample used for analysis must be representative of the original sample. It is important not to allow segregation to occur when selecting the sample. If a mechanical sample splitter is available, it can be used to divide large samples into smaller samples. If a sample splitter is not available, the sample may be divided by quartering the sample. Place the bulk sample in the center of a plastic sheet and divide the sample into quarters. Retain 1/4 of the bulk sample. If the remaining quarter sample is still too large, quarter the sample again until your sample is the appropriate size. Weigh the sample and take a separate sample of the same material to determine the moisture content for the purposes of calculating the weight of the solids in the sample. Use the standard moisture content test procedure. The first step after weighing your sample is to remove the portion of the sample that is finer than the number 200 sieve by wet washing. We want to remove this portion of the sample to prevent the remainder of the sample from forming clumps and thus being caught on the wrong sieve. However, the portion of the soil that is washed away is a representative part of the sample and must be accounted for. We will account for this portion of the sample by computing the weight lost during wet washing. Therefore, it is very important not to lose any of the sample except that portion that is actually washed through the number 200 sieve. Wet wash the sample in the sink using the deep dish number 200 sieve. Carefully wash the entire sample until you are left with only the portion larger than the number 200 sieve. Using a water bottle, carefully transfer the soil remaining in the sieve into a large ceramic evaporating dish. Before sieving the soil, it must be dried. To dry the soil, we will use the microwave oven. Place the evaporating dish and the soil into the microwave oven. Heat it until the soil is dry, using periods no longer than 2 minutes. At the end of each 2-minute period, carefully stir the soil with a clean spatula to allow water vapor to escape. Once this portion of the sample is dry, you are ready to sieve the sample. To sieve the soil sample, you must create a sieve stack. The sieves are arranged in order with the coarsest on top and the finest sieves below. The last item in the stack is always the pan. A standard sieve stack is shown. Lid, 3-inch, 1.5 inch, 3/4 inch, 3/8 inch, number 4, number 8, number 16, number 30, number 50, number 100, number 200, and the pan. You may not need all the sieves shown in this stack. The exact arrangement of sieves will depend on the nature of the soil you are testing. Once you have determined the sieves that will be in your sieve stack, Clean each sieve to remove any loose soil in the sieve and measure the empty weight of each sieve. Once the sieves have been weighed empty, assemble your sieve stack and pour the soils through the top of the sieve stack. As the soil passes through the sieve stack, portions of the sample will be retained on the various sieves, depending on particle sizes. Use the mechanical sieve shaker to aid in sieving the soil. Do not use this device until you have received instruction on its proper operation. After sieving, carefully remove each sieve from the stack. Use a screwdriver to pry the sieves apart to prevent spilling of any of the sample. Then determine the weight of each sieve with its retained soil. Reduce your data using the datasheet provided and following the procedures in the lab manual. Plot your grain size distribution curve, compute the coefficient of uniformity and the coefficient of curvature, and classify the soil. This concludes this presentation.